So yeah, after lunch, I got to try to be a little bit energetic. You know, it's the mid-afternoon. So this is a talk about Kubernetes. It's about orchestration. It's about containers. It's about Linux. So hopefully you're in the right spot. I'm going to jump right in. We got 45 minutes, and I'll probably use every moment of it, which kind of means that if you want to ask questions, maybe you can see me. I'll be by the Microsoft booth at the end. Happy to talk to you at whatever length and depth that I can. So happy to do that. So a little bit about myself. I've been a developer for a long time. I've been at Microsoft 11 years. I've worked exclusively with the cloud. I came kind of from the Unix world, then went to Windows, and then came back into Linux. So I've kind of gone full circle by now. VI is still my favorite editor, which kind of gives you a little background about my Unix roots. This talk is kind of, I consider the future. So unless you've been living in a cave, you can't help but avoid words like Docker, Kubernetes, OpenShift from Red Hat. We've got a number of different products out there, Mesosphere, DCOS, Mesos, all those are the words of modern-day distributed computing. And so I like this last quote, the future is here, just not widely distributed yet. And so I'm going to talk to you about this today, and I'm going to give very concrete examples. There's not going to be a lot of PowerPoint. Do that in the beginning to make sure we're on the same page, but after that, it's all at the command line the rest of the hour. So the paper that kind of kicked all this off dates back to my alma mater back in 2010. Benjamin Heinemann and Zakaria wrote this paper about distributed computing. It kind of redefined what distributed computing meant. And so you've probably heard of the companies Mesosphere and Databricks. The founders of those companies are the authors of that paper. Later on, another paper came along, the Omega paper and the Borg paper, which, as you know, come from Google, who kind of pioneered the use of containers at scale. And so these were really interesting papers. I recommend all of you to take a quick peek. They give you some insight about the thinking behind a scheduler, orchestrating workloads, failure recovery, all those interesting topics that have to do with orchestration. So if you look at all the orchestrators today, it's clear by now that Kubernetes is the one gaining momentum. It's an open source project. It was started by 3 guys. 2 of them are at a company called Heptio. Brendan Burns is at Microsoft. Microsoft itself is very deeply committed about Kubernetes. So whatever you write that runs in Kubernetes on Azure runs everywhere. It's the same exact software you'll see everywhere. So I think the reason for its importance is that it's fully open source. No one vendor really dominates its kind of definition. It's support in the community. And it's a very effective born-in-the-cloud orchestrator. So it's a very great way to manage your work. We'll give you very concrete examples of exactly how it works. So when you think about running a cluster somewhere on Earth, you have a lot of options. And this is just Microsoft's footprint. Obviously, AWS and Google and a number of other public cloud providers have data centers in the world. The good news is that if it runs well in Brazil, it'll run well everywhere, notwithstanding compliance laws and those sort of things. Now imagine you have carved out a set of VMs in some data center. Doesn't even have to be, could be on-prem. You have a bunch of VMs, and so now what? How are you going to do the following things? How are you going to deploy, a little louder, how are you going to deploy your apps to those VMs? How are you going to make sure they stay healthy and that they're always running? These are very difficult problems to solve, by the way. How are you going to scale up and scale down based on demand? A very important kind of thing to think about today with the mobile web world we live in. And finally, given a bunch of VMs, and I'm talking in some cases thousands of VMs running apps, how are you going to make sure that you know where they live? How can you find that app? Well, to answer these questions, there are 2 technologies that pop out of my head. Kubernetes, the orchestration engine, and then Docker containers, which are the ones that help you deploy your app. And we'll talk a little bit about those 2 now. So when you think about what we're going to do today, we're going to be an admin. we're going to work through some VM in Azure at a command prompt, and we're going to talk to the master node of our Kubernetes cluster. And in doing so, we will schedule workloads onto that cluster. And that master node is going to control that cluster. But we, as admins, as developers, will talk through some VM that's running Linux. We'll talk to that master node. And you'll see me at the command line today. I'm on that VM there, the jump box. I'm not on the cluster itself directly. I'm talking to the master node. Excuse me. So the way we provision that cluster, at least in the world of Azure, is we create a resource group, and then we issue this line here. This line here creates your cluster. And you can pass parameters, how big of a cluster do you want, and a variety of other things. Just to keep it simple, one line of code can carve out the VMs that you need. You can get more sophisticated if you like, but just to keep this clean and simple, that one line will create your cluster. Now, when you think about the portal, you're looking at the portal here on the top, you can see I've already run that command. You can see the name I gave my cluster. By golly, it matches what's on the portal as it should. It worked, in other words. So to save time, I'm not going to provision a cluster today. That's about 7 minutes. I've already run this command below, and I can show you the portal, in fact, right now real quick, and you can see the cluster up and running. Here it is. Here's my Kubernetes cluster. I'm looking at the agents, which are the nodes, the non-master nodes. OK, really good. So let's keep going here. It's only a few more slides. We're going to get into the command line here. So you know what Docker containers are about. Anyone not heard of these? It's a way to package your app with all its dependencies. So if my app lives inside of a container, I can bundle all the things it needs with it in the container. So when I deploy my container, everything's good to go, whether it's my laptop, whether it's on-premise, staging, test, production, on-prem, cloud. It's in a container. It has everything it needs. It's portable. It's robust. That's what Docker brought to the world. Kubernetes is all about doing what exactly? Making sure that all those apps running on the cluster have all those characteristics I talked to you about. That's the magic of these orchestrators. Kubernetes is one of several, and arguably the most popular, fastest growing of the orchestrators. So if I was a developer today and I wanted to make sure I had a job tomorrow, and this is the decision I made, I'm going to learn about Kubernetes. There's lots of ways to learn about it. Today is one of them. So imagine you have this cluster. You have a master node. Your end users are going to probably communicate to that master node to connect up to running apps. So I will control the cluster through the master node, and the agents are going to run my apps. That's where the apps run. Master is kind of the orchestrator, if you will, of the cluster. It schedules apps to run. What apps? What did you hear to see today? Well, we're going to run a Python app. It's going to be a website, basic kind of RESTful website. It'll have just a few methods. It's going to go to a cache, if it can, to get data. And if it can't find it in the cache, where do you think it'll go? The database. So Redis cache is bundled in the same pod. Pod is a word that we use in this world. On this next slide, I'll kind of show it to you. So our apps will run in containers in a pod. And a pod is a way to group together containers to run on the same VM. Why would you want to group together the Redis cache and the Python web app on the same VM? Well, to minimize the traffic going across the cluster to the database. Don't you want the caching layer to be with the web app to make it so less traffic travels on the network? So this is the app we're going to build, one step at a time. Now, it turns out the Python web app is a custom container we're going to build. But the other two are just ready to go. You just download them and run them as is. You don't have to do anything. They're for free, so to speak. So when we think about hub.docker.com, anyone been there here? It's a place where you store your images, your pre-built containers. And we're going to build one called PyRed for Python Redis. But the two other ones, Redis and MySQL, are public. You could just go run them. So what I want to show you today is how do I run this on a Kubernetes cluster? And more interestingly, how do I create my own container and upload it for my own use? In fact, you can go today to download my app on hub.docker.com. So when we run all these in a container, where are they coming from? They're coming from hub.docker.com, a public repository. Bruno, can I have a private one from my company? Of course you can. So these are ways to get from the public repository over into my cluster. And we're going to look at how you do that today. So if we look at the Python web app, your question becomes, Bruno, you talked about making my own image and putting it up there. How do I do that? Well, it's pretty simple. You start with a Docker file, which is just a text file. I'm going to write a web app. I'm going to write it in Python. The file name is going to be app.py. Very simple. You'll be able to read this code super easily. Once I have those two, I'm going to use the docker build command. What's going to pop out of that is an image. Now, I want to take that image and put it where? Up to the repository so other people can download it. And I do that with what? Docker push. So this is how, we're going to do these steps right now and build that out for you so you can see how it works. But the other two, Redis and MySQL, it's already built. We don't have to do anything. We just use it. One thing you should know, we're going to use an image as the foundation for our custom image, and that's Python. So there's an image in Linux already running Python. I don't need to install Python. I could if I wanted to, but why should I? There's already an image with Python on it. I'll just use it. Excuse me. So again, just to be clear, we're going to build our own custom image there, but the other two come for free. And we're going to learn the Kubernetes way of having that a reality. By the way, notice on the master node, there's a bunch of processes running that do the bookkeeping, the management of the cluster, the running and scheduling of my apps and containers on that cluster. I'm going to talk to that master to make that happen. That's how it's going to finally take place. So how do we build that image? And we're going to do the commands in front of you. I'm going to go real quick now. So that's the Docker file. Basically what this says is, go download the Python image, expose port 5000, which is how I connect to my web app, and run my custom-made program, app.py. So there is a Python repository, and that's going to be the foundation of my custom image. And I'm going to write this program called app.py. It's a very simple program. It has 3 entry points. The IP address of my cluster, /init, /courses_add, /courses, and the UID of what I want to retrieve. So it's going to be a very simple service. Initialize the database, add a record to the database, retrieve. But this will do some magic. It's going to, before it goes to the database to retrieve the record, where should it go first, based on my discussion? The cache. So that's what you'll see the code for that in a moment. I'll give you the, so anyway, just to kind of summarize it, 3 bullet points here. Well, go back a sec. Just to make that clear, I just want to make sure, because we're going to zip through the code, realize there's 3 different areas of functionality in app.py. Okay, so again, the goal is, let's create a service, which will be the entry point. It'll expose an IP address to the pod, which is running the web app and Redis. But the user never goes directly to the pod. It goes through the service. So we're going to create a service for the web app, and then we're going to create a service for the database. And this will be a private IP address. That'll be a public IP address. That'll just be for internal communication. But 2 services, 2 pods, that's what we're going to build now. Okay, really good. So I'm going to go, as the first exercise here, I'm going to go here to the command prompt, and I'm going to download the repo that has all the code that we're going to do. So I'm going to go to what happened on my screen. You ready? That's not good. What happened? Is the one here video down here? This is weird. It just stopped working. We'll try the command here. Hey, we're back, everybody. I added that for a little drama. I don't know what happened. Let's try that again. Okay, so we're going to go basically and download a repository from Git, which is all the code we need for today's session. So github.com, Bruno Terkaly, and that's my share. I'm going to go ahead and hit enter. It's downloaded. Okay, the next step I want to kind of do is show you the folder layout for that download. So I'm going to go to the root directory here and show you the build folder, the run folder, and the deploy folder with the tree command in Linux. And we're going to basically go through these files. This is going to build out our cluster. And again, all available to you. There's even a video, I think, on YouTube of this, so you can watch it later. I know I'll go a little bit brief, but I wanted to give you the full picture. So let's start by looking at the build folder, because we want to build what? Do you remember? The web app. So there's the files for it. Let's look at the Docker file. I think you know what's there already. I showed it to you. Let's make this nice and big. Go down the Python image from hub.docker, expose port 5000, and run app.py. Bruno, what's app.py? Let's take a quick peek at it. I showed it to you earlier. It's a Flask app. Flask is the framework you use to write web apps using Python. You could have written this in anything, Go, Java, Node, whatever you wanted. I just chose this because it's easy to read. So let's look at the init code. So if the user navigates to the cluster and says whack init, it's pretty straightforward. Drop the database, recreate it, create a table called courses. Okay, so and commit it, and return back initialization done. And remember, the next one here is the courses add. This is doing a post, right? So someone's going to post a bunch of data to it. And we're going to grab that data, request get JSON of what was posted, and then build out an insert statement and execute the insert into the database. Pretty straightforward. The final one's a little bit trickier, but not that much trickier. Make sure it fits on one screen here. That's the /courses, and I'll pass in a 1 or a 2 or a 3 because that's the ID of the lookup. So what's the logic here? If the actual key exists in Redis, the Redis server, then say it's from the cache. Return the data, say it's from the cache. Else, go do the select from the database, grab the data from the database, update the cache so next time it's in the cache. I don't have to go back to the database. And if you can't find it, then something's wrong. The number's not there. So the logic is pretty simple, right? Go request the data, check the cache first. If it's in Redis cache, return that. If not, look it up, put it in the cache for the future time we need to do the lookup, and then return the result. And you'll see this execute. 3 methods. The next thing is let's go ahead now and build the container. How do you actually build the container? Let's look at this script I wrote, build. Do the docker build command. Dot means what? Look in the current folder for the Docker file. So it's kind of hazy there. The period there implies go to the current folder, find the Docker file. Because what is the Docker file? It's instructions on how to build the image. Remember the one I just showed you, from, expose the port, and run app.py. So there's the build, and there's the push. Let's run these 2 commands right now. Okay, it's being built. And what's the next step? Upload it. So it's there now. So if we go look, by the way, on hub.docker.com, I go over here to my Python red, go to tags. It should say a few seconds ago you uploaded it. And I could have a bunch of versions here that you might want version 1 or 2 or 3. But now, PyRed that I just built in front of you is available to you, freshly built. It was fast because I already kind of built it before. Many of you know those Docker commands, right? I could just say Docker images, right? And I can see my image there as well. But more importantly, it's up at the repo. Do you see how fast it was? It didn't upload whatever 270 megabytes. It just knew that it wasn't different from the one local on my disk, and it didn't need to upload it again. It noticed that it had the same kind of bits in it. Okay, very good. So now we've got that running. The next kind of step here is understanding a little bit about how you basically start building these things out in the cluster. So I'm going to go to a new folder here. So let's do that here. I think that's going to be the deploy folder. Let's go to the deploy folder real quick. And on the deploy folder is the YAML files, which define how we want to grab those images from the repo and put them into my Kubernetes cluster. So if we look at these files here, you'll see all those YAML files here, right? Those tell us what we're going to do. So what I'm going to do is show you The first one, the pod itself. Whoops. Let me quit out of here real quick. Kind of awkward with this small desk area I have here. So I want to go to, what is it, web pod. Let me just do that command properly. Web pod 1. So this is what puts in the two images, Redis and the Python app. So we can see that. There's the image of the Python app I just uploaded. So this will tell Kubernetes, start a pod. This is a whole pod. In half of the pod, put pyred. What's in the other half? Do you remember? Redis cache. So let me put some line numbers over here. So there's the first image, line 17. Scroll down a little bit. I'm sorry, scroll up, and you can see the second image. So this essentially, when I run this file, it's going to go up to hub.docker.com, run them in my Kubernetes cluster. Does anyone happen to know that command line tool with Kubernetes that does this? Have you heard of this? Kubectl? Kubectl? That's the command that does this. And the command looks like this. So we're going to tell it, go run it. And you do this kubectl command. Kubectl create, and this is the name of the file we just looked at. Go ahead and run it. So what, in fact, am I telling this thing to go do? And I could do some commands here. I could say kubectl get pods, and it'll be kind of installing it. It's not really an error. This is working. It's a misnomer. So that pod is running. What does it look like if we go back to our diagram that I showed you earlier? Do you remember that diagram of the layout of the cluster? Looks like this. We just did that part. So now, inside my Kubernetes cluster, that is running. We still have three things to do. The service for that, we'll do that next. And then we'll do the database, service plus the database. But we're done the hard part. We built the container, we uploaded it, we deployed it into a pod, that's running. Let's go to the next step here. And the next one is the service itself. So let's take a quick peek at that service. And that's the file called web-svc that you see here. Very simple. Just open up port 80. So the user comes in on port 80, but then we route it to port 5000, which is where the Python app is listening, if you recall. That's when we built it. We said expose port 5000. So the user comes in, of course, on port 80, but we route him to port 5000. And I'm going to go ahead and run this thing now with the next command over here. Make sure I got the correct command. Let's go ahead and open up, run that service that I just showed you. So again, kubectl create -f, the YAML file. It's always the same command, 4 times that you'll see today. So it's deploying now. If I say, and I did this, by the way, alias k equals kubectl, so I don't have to type in the whole thing. So get svc, and the service is there. Now, what I really want to do is expose not a private IP, but a public IP address. Let's do that. Let's make sure that our web service is exposing a public IP address, because after all, the user from the outside world wants to connect up to that. So I'm going to do a command. There's a bunch of ways to do this, but this one I think is the most literal. Basically, I'm telling Azure, go open up a load balancer and expose a public IP address. This can take a few minutes. So I'm going to go down here to the part where it says node port. I'm going to say, make this a load balancer. Now when I say get service, you'll see that it's pending a public IP, which means that Azure now, the fabric controller in the cloud, is trying to provision a load balancer with a public IP. This will take a couple minutes once it's up and running. In the meantime, we got work to do. Let's first verify that step we just made so you kind of grok what's going on here. So what we just did now is we exposed a public IP address. We did the pod on the right. We've opened up the service. We're halfway there. All we have left to do really is kind of populate the database, open up a service for that database, and then kind of run this to make sure it all works. So while that thing is kind of coming up with a public IP, let's go to the next point here. Let's look at the database side of it. So I'll do this command next. Open up the YAML file for the database pod, which is quite simple, right? It's just going to go get the latest version of MySQL and open up port 3306, which is the port SQL Server likes, or MySQL, and make up some password. I could give you the password because you can't get to this thing. Why not? I'm not exposing the public IP to you. I'm only exposing it for the pod running the, unless you could do some kind of fancy SQL injection attack on me, I'm pretty safe about this. So that thing looked OK. Let's go ahead and run it. Do you remember the command for that? Please, one at a time. It's the kubectl create-f command. Kubectl, it's always the same command, except this time we're doing the database pod. And then I can say get pods. We should see two of them right now, right? We should see the first pod for the web, and then the second one for MySQL. So looking at that diagram, do you agree that it should look like this now, just to make sure we're all on the same page? We just did that part now. One step left, open up a service. And you know how I'm going to do it. You've seen it 3 times. What are the 2 commands we're going to do here? We're going to look at the YAML file for the service. Then we're going to do kubectl create with that YAML file. So I think you'll find this very familiar to you. So let's go ahead and bring that guy up. The service. Remember the service? And again, we're just exposing port 3306 so my pod running my web app can talk to the database. And that's all I'm doing here. I'm exposing a port and giving this thing a private IP address. And then you know what's here. You know this command by now. I'm not going to tell you anymore. I don't have to because it's the last time. The create-f with the service. OK, so if I say get what to see the services, remember? SVC? No, it doesn't mean Silicon Valley Code Camp. OK, so the built-in Kubernetes service that's always running, and then MySQL and web. Hey, look what we got. Public IP address for a web server. Finally, the load balancer is ready to go. So now we've reached the end of building out this cluster. So I'm going to show you now the end game of that diagram we started out on together. We've got the 4 pieces in place, the 2 pods, and we just exposed a private IP address for. The nice thing about pods in the Kubernetes world, everything in the pod responds to local host. So there's no fancy kind of networking kung fu you have to do here to have communication within a pod. Everyone talks to local host. Once you get into discussion of networking and orchestrators, it gets to be a big kind of you talk about overlay networks, and you get into all kinds of complicated questions about networking. Kubernetes makes it kind of simple. OK, so we built out 2 services and 2 pods. The next step is to what? Test this thing. Is it even going to work? So what I'm going to do next here, as part of my steps, is I'm going to take a look at the run folder. Now, notice the .20 there. That's the address that's got to get into all my scripts. So if I look at, say, this init script over here, that's the wrong IP address. I got to substitute the 20. And I got to do that in 3 of these, the query, the add command, and init. So I did a little trick here. I wrote a little Python app to do the search and replace for me. So now if I go to init, it's going to have the .20 address, so it should just work. Good. So I just did a little search and replace in those 3 scripts, so I don't have to do it manually. So now this command is simply going to do what? It's going to execute, if you recall, what? If I go over here and I say deploy app.py, right? It's going to, it wasn't that one, what was it? It was build app.py. It's going to test this init, right? So we have the init, Remember that? And we have the add that we still got to do. And then we have the query, the get, so to speak. So let's look at each one of these. So I'm now going to say bash init. So it's basically creating the database here. I should say db database created here when it's completed. Am I in the right folder? It's taken an unusually long amount of time. Hello, talk to me, cluster. I'm in the right folder. Should work. Well, this thing thinks what I could do is remote in to my cluster, and there's a portal built into Kubernetes. And here it's empty because this hasn't been refreshed. If I refresh this now, you're going to see that all the pods are here now on the dashboard. The way I did this, I ran a command called kubectl proxy, which means that this jump box is pointing with the tunnel to the cluster. So if I say localhost, we're really going on to the cluster master, because I set up a tunnel to it with the kubectl proxy command, meaning that this can see it. OK, let's go back and see if that silly command, that's really unusual. It's one of those things I rehearsed 1,000 times at work. Let me see if we can do the add. So I'm going to go over here to the add command. This might fail. So the add basically says, go hit that add endpoint, right, over here, -20, and pass in the data. And here's the data. UID is equal to 1. The course number is 401. The course title is Kubernetes, and notes. If this doesn't work, I'll just kill the pod again and try again. So I'm now going to say bash add. The demo gods again. So what I might do here as a brave step, I might go in here and say, OK, let's try to debug this. Get service. So notice we have the, it's not the service I want, it's the pod. I believe the service is working, so I'm going to say get pods. There it is, the MySQL. I'll say k delete pod MySQL. Deleted. Let's recreate it. And I believe we're going to go to the deploy folder to do that. And we have the db pod. So remember the command, kubectl create -f db pod. So let's say kubectl get pods. It says it's running. Everything should be working. If I say get kubectl get services, are they all running? They are. As far as I could tell, things should just work. So let's go ahead back to run. Take a look here again. There's the init command. Let's do our Hail Mary. We got an issue. So no need to worry here. We can do a little rehearsal here. So I'm going to go over here to this command and see if I can clean this thing up and rerun some of these commands while we think about this. So I've got here a few more minutes. So I'm going to go to the deploy folder, and I got a command to clean things up. So notice this command clean.sh. It's going to delete everything. So let's go ahead and try to run this. Maybe just rerun these commands, because they all should just work. OK, so do you remember the 4 commands? I got them here. So let's do the web pod first. Create -f web pod, put that guy up and running. And what was next? Do you remember the next one? The service. Create the service for the web. Okay, service, and then you recall that I did that editing. So I'll wait a couple minutes, make sure that thing is up and running. I'll circle back to that one. What was the other two we had to do? Yeah, that's correct. The database pod, and then with the database service. So let's go find those guys. I have them right here in front of me. So that would be kubectl the pod. So let's do that command. It's just connecting up to port 3306 of that pod.
So it names it by pod.
Yeah.
That's like a machine.
We can look at the YAML file maybe after the discussion, take a look inside there. So that's pod's up and running. What's the next one here? Do you remember? The service. So I'm just going to go here and do that. The service would be kube control, create the service. Let me get that command here. Where's that thing hiding? This one right here. So this is creating the service. And the final step is to make that load balancer come back to life. So that's creating the service. So let's verify the command. Do you remember kubectl get pods? They're up and running. Kubectl get services. They're up and running. And the other command was to kind of open up that load balancer, which I'll do here. And if this doesn't work, then there's some bizarre error, because these are definitely the correct commands. So this kubectl edit says, open up the running service and allow someone to edit the way it behaves. And in this case, we want a load balancer here. That's spelled correctly, right? So now we say get kubectl get service. It'll take a couple minutes. And going back to your question, we'll figure out how that database pod is addressed. And we can look at the pod for the website, right? So if we go over here and look up vim web pod, I got to go back to that folder, right? The build folder, and go for the web pod. So web pod 1, right? Is that the correct one? Yes. I'm just all thumbs, I'm sorry. So where am I here? I'm in deploy. There it is. How come I didn't, oh, it's a -1. -1, Bruno. You know that. So here we're basically, we'd have to look at the app.py to see how it's addressing it, I believe. So let's see, in the meantime, everyone's on pins and needles for the service. Let's see if we have a public. It's still pending. So I'm going to go now to the app.py, and that, I believe, was in the build folder. Vim app.py. The question was, how are we connecting the database from this web app? And it looks like this is the connection string right here. MySQL DB. That's that simple. That's the command to connect up to the database. Okay, let's check again for the fun of it. Still pending. In the meantime, what I can do is just verify a few of the things that we've done here. So I'm going to go and talk to you about that final command where we did the service, just to kind of while this thing thinks. Anyone have any questions in the meantime? In the back?
It's the master's job to associate the pods and services with the right VM.
Correct. So the question is, how does the master know where to run the pods? Well, you can set up rules to say, I want you to go and compact as many as you can into a single agent. Or you can say, go to the one that's the most free, go to the one with the most memory. There's parameters you can set that control how the scheduler decides where to put the pods. There's a question in the back?
In terms of doing a real-world application, am I correct in believing that exposing the public IP should be
Us.
Here you haven't even instantiated the database yet before you're exposing the public IP.
You can run, like I've run it both. It's a good, the question was, shouldn't I wait until the end until I expose that public IP? The answer is you could actually do all these individually. Like the order does not matter. Like if you run those commands in any order, the cluster will still come up. It figures it out. It's a good point. And maybe that's why we were thinking it doesn't work. Okay, we got an address. It should work. So I'm going to go back to the run folder, I believe, and do my search and replace for 220, right? So there's my search and replace, Python, search and replace. There, let's go look at my init command now. 220 is there. Bash init. It worked that time. Don't clap, because pure luck. My grandpa was right. I'd rather be lucky than smart. Let's do the add command. So now it's going to add all those 3 records. There's the first one. And let's review those commands so you understand how they work exactly. I've got 5 minutes to wrap this up, which I can do, I believe. So once again, if we go over here and cat the add command, and let's say we grab one like this one here. We can do our own if we want, just so you see the whole syntax. I'll do a copy, paste, and I'm going to go here and change some of the stuff here, right? I'm going to put 404, and instead of Docker swarm, I'll just say, do not fail me, and hit that guy in. So he's in there. Now I can start doing some queries. Now you agree this is the IP address here, so I can grab that along with courses and just pass in a number like 1, 2, 3, or 4. So I'll copy it. I'll go to a browser here like this one right here. I'll paste it in. I'll say courses whack 1, and we ought to see record 1 show up here. There we go. So it came from cache because we'd already hit it before. Let's go do 2. Success. And I do a refresh. It'll say from cache, right? If I do up, it came from the cache that time. Let's do 4, my favorite one of the day. Record not found. I guess. Okay. I see. Did record 3 show up instead? Oh, there it is, a 3, right. Well, let's do this. We can fix that. We'll put a 4 here. Unless I have some kind of primary index on the course number, which would mess me up, which I think I do, right, because it's kind of timing out. I never give up. You know that. I'm going to go to put a 5 here now. All right. There we go. Do not fail me. So I guess the moral of the story is like nothing's fun unless there's a little drama, you know, and I think we had a little bit of that. So did you understand kind of the steps to do all this? We built our own custom container. We uploaded it to hub.docker.com, and then we basically provisioned it here in Agent 1. We didn't designate Agent 1 or Agent 2. The scheduler did all that, right? And then we put up a service for every one of them. And I think you got the picture about containers, orchestrators, clusters, how to provision them. What else would I add here? This is where all the jobs are going to be in the future. This is a very important technology. At Microsoft, we're deeply committed to this because we realize this is where companies want to be. They want a vendor-neutral way to run their stuff at scale. And Kubernetes is that kind of open source way to do it. The same exact commands that I just showed you will work anywhere. Nothing that I showed you is specific to Azure, to Microsoft. None of it, not one shred of it, except for the provisioning of the cluster. That's the only part. that first command, but that's easy enough in any other environment to replicate. So with that said, I got like 1 minute. And you also saw me debug with perspiration on my forehead, which was a little fun. And essentially, I want to thank you for being here. Thanks for staying along.